Bismillahirrahmanirrahim. Assalamu alaikum and welcome back to my YouTube channel. The topic for today is related to stacking in the switches. So today I'm going to demonstrate you how to build a stack in HPE COMware switches 5130, 5140. In this series of switches, how to build a stack. So there are two general technologies for the stacking. One is like the simple one, the standard one, which require a stack module and stack cable. On the back side of the switch, you can plug the stack cables into the modules in the cross manner and the stack will be established. But other technology is, you can say, like VSS in Cisco. It does not require a special purpose stacking cable or module. You can just uh, connect those two switches with a fiber or copper cable and do the configurations, and your stack will be established. So in Aruba, you heard like VSS in Cisco. In Aruba, it is termed as VSF, and in HP COMware switches, this is the limited series COMware. So you have IRF. Okay, the concept is same. You just need two or three connectivities between the switches, and the stack will be established. Now let's jump onto the configuration. So I have my console connected to one switch, switch 1. I will consider as switch 1. So system view, I will name it as SW-1. I will make it as a master. So let's define it as a master IRF member 1 priority 32. By default, all the switches are member 1 for the IRF. But the priority value, the higher the priority is the best. So it will be make a switch. It will make the switch as a master. By default, the priority of for the IRF on any HP COMware switch is 1. So we are making it 32, or we can make it any value more than 1. So make it 32. Now I will define the interfaces. I have used port 23 and port 24 for this. Let's go into the interfaces. Interface range gigabit 1 slash 0 slash 23 to gigabit 1 slash 0 slash 24. Do a shutdown, exit. Now I will define it as a IRF port, IRF dash port 1 slash 1 port group member interface gigabit 1 slash 0 slash 23 and 24. Okay, it is asking me to save the configuration, so I will do save. Yes. Now I will enable the ports, show interface range gigabit 1 slash 0 slash 23 to gigabit 1 slash 0 slash 24. No shutdown, save. And now I will enable this IRF port configuration. Okay, this will activate the IRF on this switch. Now see display IRF configuration. You will see two interfaces. Okay, and we have one port only. So now let's jump on to switch 2. I will plug the cable now to switch number 2. It's a new switch. So let's jump into this system view, host name, switch to same connect configuration. Yes, I have same interfaces, interface range gigabit 1/0/23 to gigabit 1/0/24. Shutdown, shutdown. Okay, exit IRF port 2/2. Okay, let's first define the IRF. IRF member 1, RE number 2. This will be the second member. Yes, and save and exit. Okay, when you do the RE number mean the switch number, the port identification. Now it is 1/0/1. The other switch will be 2/0/1. So when you change the RE number, so you have to reboot the switch. So once it's come back, we will do the other configurations or the port configurations on. Let's wait. It is back now. Let's do the further configurations. Interface range gigabit 1/0/23 and 20. Sorry, it's 2/0/23 to gigabit Ethernet 2/0/24. Now the name of the interface is changed. We'll do shutdown, exit, IRF. Let's define the IRF ports. IRF port 2/2, port group interface 10 gig. Sorry, it's gigabit 2/0/23 and 24. Let's save. Yes. Now let's unshut the interface and enable the IRF. Exit interface range gigabit 2/0/23 to 2/0/24. 0/24 gig, no shutdown, save, save. Now activate this IRF ports, IRF port configuration, activate, and now once I put enter on this command, so you can see the switch 2 begins to reboot. Now we'll plug the console back to switch 1. Let's see what is the status there. So once this switch 2 come up, we'll see these two switches with a part of the stack, one logical switch, and the switch 1 will be the master, and the switch 2, which is rebooting, will be act as a standby. Let's wait again to reboot this switch and we will do the verification. From the logs, you can see IRF port 1 came up. So let's verify display IRF master. Let's wait few minutes more. Let switch 2 come up. Now you can see the other switch came up, and this one is switch member ID 2, standby, priority 1, and serial number this one. Okay, so this will act as a single logical stack. If we see the interfaces, show interface description brief. So you will see like port 1, this is for the chassis 1, and this is for the now started for the chassis 2. And I have used the copper cable, two copper cables to build up this IRF for the demonstration, but it is always preferred to use 10G fiber optics cable to build up this IRF stack, because if you use the copper cable, so it will give you only the capacity of 2 gigabits. The communication, the data transfer between the switches, the total communication channel between the switches will be only 2 gigabits. And if you use 10G interfaces, 2 or 3 or 4, then your communication channel between the switches, the data channel, the control channel will be with a more capacity. So we always prefer to use a fiber cable 10G, or if there is a 40G available, so to uh, give the more capacity of communication between the switches. Thanks for watching.